Okay, chapter 8.3, solving inequalities using multiplication and division. And the first thing we need to understand is the property states that if you multiply each side of an equation by the same positive number, the inequality remains true. And we have to remember that it has to be a positive number. When we get into integers, negative numbers, etc., we'll find that there's maybe some different rules. But when you multiply each side of an equation, the inequality remains true. For instance, if 8 is greater than 6, and we multiply 8 times 2 and 6 times 2, like this, we want to know, is it still greater? And 8 times 2 is 16, 6 times 2 is 12, and so it's still true. And in the same way, if we divide by a number, say we divide by 4, let's use the fraction bar. It's always what we should do. Pretty much always what we should do. 16 divided by 4 is 4, 12 divided by 4 is 3, and 4 is still greater than 3. So you can kind of see the progression as we go through. If we use algebra, it looks like this. X over 4 is less than 2. Okay, so this is like x fourths, or x divided by 4 is less than 2. And if we multiply both sides, use multiply by 4 ones. And the reason we do that is because 4 ones, make sure that we understand that the 4 is in the numerator and this 4 is the denominator, and those cancel to make 1. 4 fourths is 1, so that leaves us just the x. And if x fourths is less than 2, then x is less than or equal to 2 times 4 ones, which is 8. So x is less than 8. So if we were to put in a number greater than 8 and divide by 4, it wouldn't work. And I'll show you real quick. The original problem was x fourths is less than 2. So if we chose a number that's bigger than 8, and we're going to choose something that works really well with 4, so we're going to choose 12. So we're going to say x is equal to 12, and we put that in. 12 fourths is less than 2. Well, 12 fourths is equal to 3. 12 fourths is 3, and 3 is not less than 2, so that doesn't work. But if we were to try a number, so remember we're using this x less than 8, so if we use a number like 4, and instead of using x equals to 2, because or x equals 12, that doesn't work. Let's try x equals 4. So if we put 4 in here, 4 over 4 is less than 2. 4 over 4 is 1. And 1 is less than 2, so that does work. Ta-da! And that's basically what we're doing. If we look at example 1, it just wants us to solve. It's just like we did with the equations, but we're using it less than and equal to, greater than equal to, those kinds of. So it's an inequality, but it works the same as an equation as long as we're multiplying and dividing by positive numbers. So example 1 is x over 5 is less than or equal to 2. And what we do to solve this problem is we multiply both sides by 5, which looks like this. X over 5 times 5 is less than 2 times 5. And we continue on. We can simplify or cancel out those 5's, because 5 over 5 is 1, and that leaves us with an x, and 2 times 5 is 10. So x is less than 10. And on a number line, because we always have to graph it, looks like this. We start with maybe 5, 6. I guess we'll go by ones, because of course 10 is way over here, but our number line can go forever in any direction. It's less than, not less than or equal to. So it's a hollow line, a hollow circle, and that's not going to be filled in. And it's less than 10, so our arrow is going to point this direction. You can make that look nice and straight if you use a ruler or this little handy tool. Make it look just a little bit more arrow-like. And that's the picture of the graph. So that's example number 1. Example number 2 is similar, but we have to use division instead. 4n is greater than 32. So if 4 times n is greater than 32, if we want to figure out what n is, we divide both sides by 4. Okay, and then we simply, those simplify down to 1, so that leaves n, and 32 over 4 simplifies down to 8, because 4 times 8 is 32. N is greater than 8, and that's our answer. If we put that on a number line again, 6, 7, 8, 9, 10, 11, 12, and of course the number line goes forever in both directions. It's not greater than or equal to, so that means that we have a hollow circle on 8. And since it's greater than 8, n is greater than 8, notice our arrow is pointing that way. We're going to point our line that way too. And that's our graph. Greater than 8, so 9 works, 10 works, 11 works, 12 works, and every number bigger than 8 works, and as well as some of the numbers that are decimals like 8.1, 8.5, things like that. Example 3 is another real-life application, and I'll try to go a little quicker than last time. A one-way bus ride costs $1.75, so this is one way. Oops. Go back to our other tool. One way, so it goes one direction. It's not a two-way ride. It's $1.75. A 30-day pass is $42. 30-day pass is $42. Write and solve an inequality to find the least number of one-way rides you must take for the 30-day pass to be a better deal. Okay, so when does the one-way rides, when does the one-way rides, when does it become more expensive or greater than the pass? This is really when does the one-way become greater than the pass? This is kind of our question. Okay, so they've got the one-way ride times the number of one-way rides is greater than $42, because we have $42 as one of our numbers. So greater than $42. And the pass is $1.75. I can see I'm going to need a calculator. And we don't know how many of those. That's going to be times, we'll call it R for one-way rides. So, okay, one-way ride. So however many of these, if we bought one R, it would just be $1.75. If we bought two, it would be 2 times $1.75. If we bought 3, it would be 3 times $1.75, and so on. We want to know when this gets bigger than 42. And so really what we have to do is we just have to use division, divide both sides by $1.75. And this is when a calculator works really good, because it's a little hard in your head to figure out 42 divided by 175. And it's okay to do the long division there, but it's also okay to use your calculator. So we're going to remember that it's 42 divided by $1.75. We have to go here, clear it out, and then say 42 over, which is divided by $1.75, and I must have hit clear. So real quick, equals 24. All right, and then that makes sense. Let's get back to this screen. So R is greater than or equal to 24. Oh, equal to. If it were equal to, then that would be if you got 24 one-way rides, it would equal the $42. Notice that when 42 divided by the number 1 would be just 42, but when we divide by a number bigger than 1, it's less than 42. If we rounded 175 up to 2, 42 divided by 2 is 21. But it's less than $2, so it's $1.75, so that gives us 24 rides. And so our rides, we have to take more than 24, and I guess we could even graph that if we needed to. But I don't think we need to. So our rides equal more than 21, or more than 24. So this is the answer in phrase form. And that's really all there is to it for this lesson.